Welcome to another video. Today we are dealing with the calculus kinematics equation involving displacement, velocity and acceleration. So given that the displacement of a particle moving and the displacement is given by s is equals to 4t minus t squared. So find the velocity and acceleration. So we are going to take you through step by step up to the final solution. If you are coming across this channel for the first time, kindly subscribe. Remember to like, leave a comment, and turn your notification on. So we're going to start with the series of questions. The first one, we are told, how fast is the body moving at t is equals to 1 second. So we are told to find the velocity when t is equals to 1 second. But recall that given the displacement and you're asked to find velocity, then you need to know that velocity is the derivative of displacement with respect to time t. So for our case, the displacement is given as 4t minus t squared. So for us to find v, or velocity, then if I find ds dt of this particular equation, I'm gonna get 4 minus 2t, the derivative of this equation. So our first equation was find the velocity at t is equals to 1. So meaning that I'm going to substitute t in this particular equation so that I have 4 minus in bracket. So I'm going to have 2 where there is t, I substitute 1. And you end up getting your velocity is equals to 2 meters per second for that first part. The second part, we are told to find the maximum displacement, find the maximum displacement that the body will achieve. Maximum displacement that the body will achieve. So at maximum displacement, you need to know that at maximum displacement, our velocity will always be 0. Remember that particle is moving from certain point according to with respect to time. So at some point when the particle will be at maximum point, the velocity will be at rest. So that means at maximum displacement, our v will always be equals to 0. So that means ds dt is equals to 0. And for our case, ds dt was 4 minus 2t. So I'm going to equate this to 0. Next, I'll be able to find at what time from this equation, and we're going to find that taking this on the other side, I'm going to end up with 4 is equals to 2t, and my t is equals to 2 seconds. So our body will be at maximum displacement when it is only 2 seconds from the initial starting point. So when I substitute t is equals to 2 in our displacement function, which was 4t minus t squared, I'm going to end up with 4 multiplied by 2 minus 2 squared. Of course, this is 8 minus, when you square 2 you get 4, and the displacement will be 4 meters. So after some 2 seconds, this particle moving at this displacement, or that relationship, will be at maximum at 4 meters. Only after 4 meters, then the speed or the velocity will be at maximum. So guys, next question, we are asked to find the acceleration of the particle that we have there. And you need to recall that acceleration, I'm going to recall it A, is equals to the derivative of my velocity with respect to time. But remember, I have my velocity function here. So taking its derivative, I'm going to get A is equals to, A to mean acceleration, is equals to, when I differentiate this, it disappears. And when you differentiate this, it remains negative of 2 meters per second squared. What does this mean? So this means that the motion of the body is constant all through when it is negative 2. That is the representation of it. So guys, we have the last question where we are asked to solve the time. Time taken for the body, the time taken for the body to be back at the starting point, So meaning that this particle is moving in an oscillation manner such that when it goes, it reaches some maximum point or velocity point, and then we are being told that this particle will be back again at the starting point. So how do we tackle this? So at the starting point, remember our displacement function S is equals to 4t minus t squared, meaning it is the pattern that this body is taking at any given time t when it is moving. But recall that at the point of the starting point, the particle is not moving, meaning S is equals to 0. When it reaches the maximum point and returns, the displacement or S is equals to 0. So applying that, I'm going to have 4t minus t squared. 4t minus t should be equals to 0. So this is a quadratic fraction. I can factor out t. And then I'm going to have 4 minus t should be equals to 0. So since this is a product of two functions, it is either t is equals to 0 or 4 minus t is equals to 0. So this goes without saying that at that point where the body will come to the starting point, it will be at 0 seconds before taking any motion, and at t is equals to 4 seconds. So this particle is like it is oscillating, going and coming back. So after 4 seconds it will be at rest. It will be at rest, and then at 0, so I think it's like this. So the body is moving at that particular point, that is the starting point. It oscillates like that. At this point, t is equals to 0. T is equals to 0. And then it goes and reaches a maximum point at t is equals to 4. That is what it means. So guys, we have come to the end of this tutorial. Kindly, good people, don't forget to subscribe, like, comment, and share. Until we meet again in the next video, goodbye for now.